Well, thanks everyone. Thanks to NetUK for inviting me. I've worked in networking for, well, not that long, because obviously you can tell I'm very fresh-faced and young-looking, but quite a long time on the enterprise side of things. So I am one of those non-service provider people, although I have done some work for service providers, some consultancy work. So what I'm here to talk about is an open source project that we've put together based on our experiences over the last 10 years. I heard there's a couple of comments actually earlier about 10 years being a long time and the nuclear industry being a long life cycle kind of endeavour. So I move to the first slide. Yeah, so 10 years ago, when we started, my expectation would be, like Gordon says, network automation done, but it's not done. It's not anywhere near done. Things have changed a lot over that time. So when we started providing automation solutions for enterprise customers, there wasn't much out there at all, really, to the point that we had to build our own web servers, write code that ran in the web servers, all that kind of thing. So in that time, there's a lot of platforms that have become available. You'll see things like Terraform, Ansible. I think Ansible was a thing then, but it had only just started. Adoption of Python, so Python coding, become much more prevalent, and there's lots of modules available, frameworks, that kind of thing. What seems to have happened is there's no single solution. People use all these different frameworks, and it's kind of a patchwork of solutions that build up. Companies particularly will have different silos in an organisation, and they're kind of doing their own thing. Some will use Ansible, some will use Python, some will use Terraform. You know, they're all, or however they do it. And I think a part of that is because it's being driven up from the bottom. So I did a whole presentation actually on why I think network automation isn't further along the line than it is now. There's some obvious things like the criticality. I think that inhibits it. But it's also the fact that it kind of becomes like a spare time activity for people. So they have their own day job to do, and then they start trying to automate stuff and write scripts, and then it becomes a chore and a burden. So it's not really supported top down. When we started, there were a few products available, but they were in the mould of these sort of big company enterprise systems. Some of them still exist, that seem to cost a lot more money than the value you got back out of them. And they were very prescriptive about how they'd do things. So if you didn't want to do something the way that system wanted you to work, you could bend it a bit and make it work, but it was hard. So Snowflake, so every organisation is different. There's common themes, but they've got their own standards, their own way of doing things. So you kind of need to have custom code. It's necessary. I haven't yet seen a product that you can just go install and it will do it. And I don't really think there ever will be one. So what are the common problems? So what we find is when we go into an enterprise, they may have something that they want to do, and we'll talk to them about what it is, and we'll work out, yeah, we can do it. We can write some code that will do that for you. We can read your data sources. We can connect to your devices, etc. But the common problems are, well, where do we run this code then? Who's going to have access to it? That access needs to be authorised and authenticated, probably. There probably needs to be audit trail. If you're accessing privileged systems, you need credentials that are going to do that, but you need to keep them safe, basically, away from general users who can just pick them up and have elevated privileges. So these are the common things. We also think that the best people to automate a system are the people who are already running it. So you can't automate something if you don't really know how it works manually. The first thing is what do we do manually? Out of that, what part of that process is necessary and what part is sort of just historic, that's the way we do it. So there are some elements that can be changed, but you have to start from that point and then automate it. So how do we sort of live in this federated world, I guess, is the question. So this is what we've come up with, an open source product that will address these common problems, but not dictate how you do the automation. So that's still up to your code. We've been helped with emergence of Kubernetes, so that solves some of the problems, or really containerization solves some of those problems. So usual problem you get if you're writing some code for someone, if you've got requirements, they have to be a certain version, all the packages you need, getting that environment to be consistent. Obviously containerization solves that, because you can build a container, you can load that on your, wherever you run it, on your cluster, and your app will run, or your code will run as you expect. One of the issues with Kubernetes is it's perceived as being complex. I don't think it is. There are a lot of moving parts to it, but it's not impossible to learn. But there is a learning curve. So this takes away the necessary knowledge of Kubernetes. So you can run this, you can get your code up and running without really knowing anything about Kubernetes. The other thing that Kriten does is it builds an API access point for you. So once you've written your code, you can load it onto Kriten, and the API access point is available. So that means you can then say to whoever you want to consume your service, here's this API endpoint, here are the parameters you need, and that will kick off your code. So the idea of this is, if you have got these different silos of people who are experts in what they do, they've written code, usually quite often people will write code for their own benefit. So, I've written a piece of code that will go and get me free network addresses, or this kind of thing. There might be other people in the organization who need that, but you can't give them privileged access, you haven't got a server for them to run it on, that kind of thing. So this addresses that problem. So silos can still run their domains the way they want to run them, but also cooperate, so you can make things safely available. So I've got a very silly example. So this is an Ansible playbook, and it will just, if you don't know about Ansible, really Ansible is a way of running Python scripts. So there's a standard set that are Ansible modules. You can write your own code in Python, turn it into a module, that kind of thing. So what this does is, Ansible also takes an inventory. So you have an inventory of hosts, so you can say, run this script against these hosts. So what it will do is you give it the list of devices, and it's going to just do a show version command, simple stuff. So not an example you'd actually want to put in production, but the point that we're going through here is I'm just going to show you what you do to go from that point to making it publish. So where we are now is on that last slide, it works on my laptop kind of position. You've got some code, you've tested it, you can run it against devices, and it will give you the results back. This example is available actually on the URL listed there. So this just sort of steps you through the manual processes of what you would do. So this is a Python thing. So what you do in Python is you'd make a virtual environment, which is a place where you can load your specific packages. You'd install those packages. There's something called pip that does that. Then what we're doing is we're exporting some values that the script is going to use. So the script is going to read those values, those M variables, and use those to run the code. So we do that, and then we run the command. So the last thing there is the Ansible playbook -I for inventory, and then the playbook itself, and some extra vars. So yeah, we've saved, you can see the extra vars we've saved that as a variable there called extra vars. So this is just saying run it on all hosts. There's only 2 in this inventory. This is the kind of, below that is the kind of output you get back from an Ansible playbook, and this one's just showing you, the bit in there is kind of familiar territory there with a version and all that stuff that comes direct from the device. So what you need to do now is you need to build a container. Now, how enterprises generally run this is they'll have a container registry which hosts all of their containers. Now, how they do that depends from organisation to organisation. So you could, for example, say, I'm going to build a container that's my standard for network automation. It's pre-built with all the packages you're allowed to use, and you use that. The other end of that scale could be, for every script that you write, you build a container that has exactly the packages you need and no more. So you'd end up with lots of containers in that kind of, or lots of container images, sorry, in that kind of environment. So that's up to sort of organisational preference, how you do that. What this is showing is a Docker file. So Docker images are built up in layers. You usually start from a pre-existing one. So at the top there, we're saying we'll start from this Python 3.9 image. Then the rest of it look like the commands that you would do anyway. So we're saying make a directory. The requirements text file lists all the packages we need. We do the install, the pip install, which installs those packages. We've got to set this extra flag there. This is just an Ansible thing that if you don't do it, you'll get that, it'll get stuck because it will be, you know, when you SSH on and it says, do you know this, accept this key, it will stick at that point. And then the command. So in actual, this command that we code here is the command that's used if you don't specify a command, but usually what you do is you override that at runtime anyway. So then you do a Docker build, Docker push. Now again, so I've been talking about at the start, well, you don't need Kubernetes expertise, this, that, and the other, and you're probably thinking, well, that seems like a lot of work to do. But you could be in a position in your environment that you've already set all this stuff up. Yeah, so you've already got container images that have got the things that you want to do. They're already stored somewhere, so you don't have to do all that. Just for completeness, I'm showing you the whole process here. So Kriten is an API-based system, but we've written sort of a very basic admin GUI for it. So I'm going to use this just to show you the step through the process. Each of these things, these 2 boxes here, create runner and create tasks, you just do with an API call, but this just shows you the parameters that you need. So we've got 2 concepts here. We've got a runner and a task. So a runner, it's probably badly named because it's something that doesn't run. But anyway, it's what it really is a set of, it defines the environment that you want to use. So you're in the runner, you're specified the container image that you want to use, and you're specified the code repository where the code lives. So again, this is also sort of enforcing good practice. So sometimes you get the issue, and managers hate this, when different departments have their code and scripts and they're sort of stored all over the place, this kind of thing. This enforces source control management, so your code's got to be in a repository. Again, how you organise that is up to you. You could have one repository that's like a network tools repository that's got all your network playbooks in. You could have like a company-wide one, a smaller one. That we don't prescribe how you do that. You just have to have it in a repository. I think there's branch in there as well, so you could, with code in a Git repository, you can have different branches. So you could have a development branch that you're updating your code against, and then when it's accepted, push it to a prod branch, that kind of thing. So you'd create like a development runner in that case. Then the task references the runner, and what the task does is it says, from this environment, so using this image and this repository, what is it that you actually want to do? And so this will be in our previous example, that will be the Ansible playbook, blah, 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 with all that kind of stuff on. You can also specify the parameters. That format there is actually Open API spec. So we've given an example, a simple example where you say, so you've got one parameter that's called target host, and it needs to be like 1 character long, this kind of thing. But there's lots of different things that are available in that spec. So you could do things like, I want my parameter to be a value that's a value from a list, like if it was prod or dev or something like that. There's all kinds of things you can do there. And anything that's Open API spec compliant can go in there. We've got, there's a work in progress to actually make that graphical, i.e. when you look at that from the UI, present that in a graphical form. So if you had a drop-down, if you had a list of options, present a drop-down with the list, rather than just this sort of text version of it. Then at the bottom there, we're looking at, these are the secrets that we want to pass. So these things will so they're visible now when you create the task, but that's the last time they'll be visible. They'll be saved on the cluster as, there's an object type in Kubernetes called secrets, so they'll be saved there. So that's all the setup done. Now this horrible screen is just how you would run an API call from the command line. It's the most simple way, so just use curl. What we've done here is to simplify it slightly. The Kriten API is specified as a variable. Then you run curl. You need a token to log into Kriten. So what we're showing here is there's a first step to log in, and we're just using default credentials. We save that token, and you can see the first step there, you get this token back, and then you can use that for subsequent calls. It lasts for about 5 minutes, I think, but that's configurable. So now you've got the token, you issue another curl call, that's sort of like a third of the way down there, and it says curl, Kriten URL, and then we put this has been created when we created the task. So we created it and called it network Ansible show version, and that's what you run. So now you can say to your user community, here's the URL, you'll need a login, and the login, there's RBAC built in, so you can say this user is allowed to run this task or not, all that kind of thing, and then they can run that. So, and they'd get the result back. So no need to give them credentials to anything. They don't see the code. All they can do is run that command, or run your code, and that your code being whatever it is that it does. So how it's supposed to be used, rather than using curl commands, is we only wrote a very simple front end because the business of this is to just enable you to run your code and make it available. We don't be, and how you want it to look is a whole different thing. So we make the code available as an API endpoint. And then companies have either company portals or CI/CD systems or something like that that will actually call the API. So that's really what this is showing here. So Kriten lives within this sort of light blue box here. It's a Kubernetes cluster with Kriten installed. What's happening under the scenes is once you've configured it, when someone calls that API endpoint, it will start a Kubernetes job and post the results back. Actually, there's two methods of running. You can either run asynchronous or synchronous. So we don't know in advance how long your job is going to take to run. It could be like here, a show vert on one device, or it could be back up your entire network, which could take hours. So in synchronous mode, your code will run, the API will wait and return the result of your code. Now, you're subject to timeouts and that, so your code can't be very long before HTTP timeouts will kick in and you'll get a bad response. So if you've got something that runs longer, you can run in asynchronous mode. And what that means is when the user hits the API endpoint, it will immediately return a job ID. And then to find out, to actually get the results, you just go and query the job ID. So if it took 2 hours to run, it would be running until it finishes and you get the result. So we've got some people from NetBox here. So I don't know if you guys know about NetBox, but it's a database, network source of truth. And the NetBox system allows you to put your own scripts on there. So what I've done here is I've written a very small script that just collects parameters. So this is a tiny thing, and you could make. So this is actually very generic now, because what you can do here is say, my Kriten URL is, and you can put username, passwords in. You could even have those already hidden behind the scenes, or use an API token. So another feature that we're working on is, if you don't want a user ID password, you could say, just generate me an API token that I can embed in some other system. So we've actually got that feature now. Yeah, and then just run that code. So from this UI, you could run a Kriten job. NetBox does a nice... So all of this stuff at the top is all just part of the NetBox system. It will run it, it will tell you that it's run, and then we just return the output. So again, that's just one example of how you can concentrate basically on the business logic of what it is you want to do, rather than building UI systems and all this kind of stuff. You don't have to, all the authentication's done for you. You don't have to build all that. You don't have to know how to build a REST API or any of that stuff. So that's the idea of it. This complicated slide is supposedly trying to make it look less complicated, so that's a bit of a fail. But this is just showing you the relationship between the objects of Kriten. So, and that's it really. You have tasks and runners, and then the user hits that. So we've got some other things that are in the pipeline. We use this ourselves. We've got a big customer project that we're doing, and we just want to put it out there in the community for other people to use. You can run your scripts on it. In the example we did Ansible, I've been talking about Python, but anything that can be containerized can be run. So if you've got something written in Go, C++, probably Windows, if you really want to try that. So yeah, good response there. So the things we're working on, so scheduling. So at the moment, it's like you run it, and at that time, it's on demand, it works. You might want to do something like set a schedule to it, so it runs like every hour or something like that. The other more advanced scheduling you might want to do is say when someone asks for it, it doesn't run immediately, but it can run, say, within a work window, something like that. Deployments, so this is all job-based, i.e. your program the user will start your program, it will run, it will end. But what about if you want something that's always running, like you want to subscribe to something, potentially? There's lots of use cases where you might want to subscribe to SNS in AWS. You might want to subscribe to your own systems. If you're using Cisco ACI, they have a subscription thing that you can subscribe to. So that's kind of where that's going. The administration UI is there, but we're not UI developers, so it's not pretty. Crit-CTL is a command line thing. So if you've ever used Kubernetes, they have kubectl. So you can say kubectl issue your command. So crit-CTL would be able to, all that stuff I did in the GUI, you could create a pre-built manifest file and say crit-CTL apply, and then it would apply it for you, which is quite handy if you've got quite a few things to apply, rather than doing each one by hand. Yeah, and any new features, we're completely open. We're at the stage now, I would say, where it's you'd call it an MVP. It's got enough features to be useful, but I'm sure there's loads out there that still need to be added. And we're really looking for people to use it and feedback what they'd like to see in it. Because we've kind of put our ideas in, but I'm sure there's lots more out there. So that's it. We've got if you send an email to the support at Kriten.io, it will trigger a Jira job on our queue, and we'll get back to you. Any questions?
Thank you, Steve. Do you have any questions? We have a question.
Oh, this is worrying.
I told you not to give him the money.
It's Dave Gethings, will be quick. What's the kind of minimum system requirement? Obviously, like the more things you do, the more jobs, the more resources you're going to need. Yeah. But as a bare minimum, what would you kind of need to run this on?
So this is really a Kubernetes question. So normally you'd say you'd have like three. The minimum spec is you'd have 3 hosts for redundancy. I mean, you can run a Kubernetes cluster on your laptop. There's things like Kind and stuff that will do that. You'd get 3 VMs. With something like a 4 gig RAM. They don't have to be massive spec. 3 would give you some redundancy. You can even, some people, for like a lab type system, you can have 1 controller and 2 worker nodes. So you haven't really got redundancy of the control plane, but it's easier then to add more workers to scale up. Or you can, just for a lab, we do it quite often, it's just 3 nodes, all roles on all nodes, and it just gives you 3 hosts you can use.
Okay, cool. Yeah. And I'm guessing the documentation might say more about how like the authentication piece works. Yeah. I didn't go into that. So the RBAC of it. So we've used the same kind of RBAC module, sort of a scheme that other systems use, where you create roles, you create users, then you attach the users to roles and that kind of thing. Yeah, okay. And there's Windows Active Directory integration. So another thing on the features list is like other authentication providers. We just did that first because we think that's probably the most common. But if you want to do Kerberos or something crazy, we could do that. Cool, thanks very much.
No more questions? Oh, well. Thank you again, Steve.
No, thank you.